Hello and welcome back to KXAN Plus. I am your host, Esmeralda Zamora, and today we have our space-based segment. We've been gone for a while, but we're finally back with our KXAN space expert, Eric Henrikson. Eric, thanks for joining me. How are you doing?
I'm doing great. We have been gone a while, not because we wanted to be, because life gets in the way of things. I was on vacation. We were trying to do some stuff. We had a couple segments pop up that you had to do while I was trying. It was like kind of chaotic the last few weeks. But things are starting to settle. Obviously, we had like major breaking news that we were off on. I was not even in the city for a little bit. So we're finally back to a normal routine.
Schedule.
Kinda.
Back to normal,
Kinda.
but still here with our space show.
Yes,
sure.
we're back. We're back for sure. We're here.
And
we're
today,
here in the building.
You're going to talk a little bit about hot Jupiter, but not really Jupiter, just a hot
It's not
Jupiter.
our Jupiter, but it is a hot Jupiter.
What do you mean by that?
Okay, so there's this planet, the proper name for it, and I do love proper scientific names because is
not?
HIP 67522b, which is very, very cool of a name. And it's a planet about 400 light years away from us. So it's 400 years at the speed of light. So pretty far. And this planet's about the size of Jupiter, except it's right next to its star. Both this star and this planet are relatively young, and the star is making this planet very, very hot, while at the same time destroying it. And scientists are able to observe this phenomenon for the first time ever.
For those of our viewers who don't really know what it means to be so close to your star, how far away is Earth away from our star?
Oh, I don't know the exact miles, but we're in what's called the Goldilocks zone, which is the right amount of distance where if you're too close to the star, like Venus, Mercury, Venus has a thick atmosphere, so there's other stuff going on there, but you're too close where water turns to gas really quickly. And if you're too far away, say like Mars is kind of in a weird spot because it kind of might have had water, but like Jupiter, Saturn, Uranus, Neptune, Pluto, that kind of section, you get too cold. So there's this Goldilocks zone. So Earth and Mars and Venus are kind of like in that Goldilocks zone. We're in the right spot.
Right.
Venus is a little weird because its atmosphere is so thick that it's like really bad greenhouse gas. It's a very volcanic planet. So it's very, very hot, very, very hot. And Mars, its atmosphere was stripped off of it at some point in the past. And as a result, there's no water on it, but both of them are kind of in the right zone where water could exist. Earth is really right in the perfect spot. So we're in what's called the Goldilocks zone. So it's the right distance away from the star. I guess miles doesn't really matter when you're talking about like the size of the star we're talking about and the temperature, because bigger stars obviously are bigger and they're hotter. So we're in the Goldilocks zone. This planet is more equivalent to like Mercury, which is right up next to our sun.
Yeah.
This Jupiter, hot Jupiter, is right up next to its star. So pretty close.
When you say that this planet is being destroyed by its star, what do you mean by that?
So the star is a baby star, and when you're a baby, you have temper tantrums, and that's true for stars just as much as it is for humans. So it's releasing these solar flares. Now ours does this too, right? It has solar flares, has solar storms, but baby stars, this is more common. And because of the proximity, because of how close this hot Jupiter is to this star, as it's releasing these flares like that one you see on your screen, it's actually stripping off chunks of this planet's atmosphere.
Wow.
It's like ripping it apart with the intensity of these storms.
So destroying it pretty much.
Yes, or I don't want to say destroying, but like decimating it.
Pulling it into pieces.
Yeah, ripping pieces off,
apart.
ripping chunks apart off of it, to the point where over the next 100 million years, this planet that's the size of Jupiter, roughly, is going to shrink to the size of Neptune. So significantly smaller, still very large, but significantly smaller over 100 years. And if you want to be super nerdy, it's 400 million light years away, right?
Yeah.
So it's 400 light years away. Over the next 100 million years, it's going to strip off. So really, part of that, it's already smaller now than what we saw. It's 400 years smaller, if that makes sense. Because whenever we're talking about light years, we're really looking into the past. So we're looking 400 years into the past. So it's already smaller than what we're seeing, if that makes sense.
It's already getting to the point of destruction.
Nah, not quite, but it's, and the planet probably won't be destroyed. It's just going to shrink because of these large chunks. And then over that time, of course, the star is going to settle. It's going to reach adolescence, and eventually, stars live billions of years. But it'll get a little older, and as it gets older, it's going to cause less damage. It'll be less destructive. Our sun has solar flares. It has solar storms, but it's over an 11-year cycle. So we see a peak at every 11 years, and then it kind of dies off again, where the storms aren't as intense.
I feel like we're in the peak of it.
We're in the peak right now, actually. We're on the other side. The peak was last year, so we're like right on the other side of the peak. So we're in the 3-year peak period that exists around that peak. But yeah, we get more storms. We get more aurora borealis during that time because it hits our atmosphere. And we get more, and like solar storms can do damage to our satellites and electronics in space. And so we have to kind of be careful around these times. Well, this planet's much closer, and the star is much more active and just taking chunks of its atmosphere away. Roasting it was the quote the scientists used.
Roasting it.
And the scientists, they are based in Europe, and they first published their work this month in the scientific journal Nature, which is why we're talking about this now.
Yeah. You shared some notes with me, and as I'm looking at them, something that you just mentioned was that the star is going to be getting smaller and smaller. Right now, we're calling it a hot Jupiter, but what could we compare it to when it's reached its smallest size?
Hot Neptune.
Hot Neptune?
Hot Neptune, yeah.
So it's going to get really tiny.
Yeah, and I don't know if it'll be its smallest, but that's the next size they're thinking over the next 100 million years or so.
Wow.
Yeah.
So eventually it could just get tiny, tiny, tiny and disappear?
Yeah, I don't know, tiny, but smaller, significantly smaller for sure. Scientists have thought this could happen before, but this is the first time they've observed it, which allows them to see now that it's going to happen in other places, and they can observe it in those places too. The amount of activity they saw and the amount of damage it saw, the scientists say it's about 100 times stronger than they initially anticipated.
Wow. So
pretty intense, but that's what science is for. You observe these things, and you're like, oh, that's cool. That's how that works.
So they've never seen this happen before?
Right. They've expected it to happen, but space is big, and stars are small, and planets are small, and so you're like, you're trying to find that kind of tiny thing somewhere off in the distance, and that's hard. So tracking down the right planet that this is happening to has been a challenge, and luckily they've done that. So now we've observed this, and we can expect it. If you observe it one place because the universe is infinite, you can expect it to happen in other places as well.
And Eric, what kind of tools did they use to discover this or to monitor, measure?
They used a satellite launched by the European Space Agency. I don't remember the name of the satellite right now, but it is a solar observatory satellite. Yeah.
So they have the tools for it.
They have the tools. Speaking of tools, we're actually about to launch a new one. I'm going to pivot to the next topic. We're about to launch a new one, but this one's not going to be looking at the stars. It's going to be looking back on Earth. It's called NISAR, and that's going to launch hopefully no sooner than July 30th of this month. And I got to talk to NASA this morning about that, and I kind of want to show that interview. You ready to show that interview?
Who exactly did you talk to?
It was an astrophysicist who worked on the program. So check a look at this.
Let's look at it.
What is NISAR? Just kind of explain to me, what is this new device we're putting up into space, and why is it important?
NISAR is a revolutionary mission that will systematically map every inch of the Earth, both land and ice, through day and night, roughly once every 6 days. And NISAR is actually the first ever hardware collaboration between NASA and ISRO, the Indian Space Research Organization. And this has been 10 years in the making, and we can't wait to launch this amazing mission.
We have a lot of satellites that map the planet in various ways. What makes NISAR's technology different than the ones we already have up there?
NISAR is actually the first Earth-observing satellite to have two kinds of radars on board. We have the L-band radar, with its longer wavelengths can penetrate deeper and look at structural shifts and study earthquakes and landslides. And on the other hand, the S-band radar can look at more finer details and study things like crop structure and wetland dynamics. And so together, these two radar eyes can give us a story of the Earth as a living system.
How do you study earthquakes from space? Typically, I know we drill holes and do all sorts of stuff, but how do you study an earthquake from space?
So one of the biggest strengths of NISAR is that it can look at extremely subtle changes in the Earth's surface, in fact, down to a centimeter. And so with this level of unprecedented detail, we can look at major fault systems and look at the stress that's building up and also figure out if there are earthquakes that are waiting to happen. And over time, with lots and lots of data, we can look at hundreds and thousands of earthquakes and update our models. And NISAR will thus help us serve as an early response system to these kinds of earthquakes and also to the regions that are most prone to it.
As you know, Texas went through severe flooding in the recent weeks. We had some locally in Austin, some to our west. Could something like NISAR help us in the prediction of those floods?
So NISAR will look at processes that include soil moisture in flood-prone areas. And when it comes to floods, if NISAR is actually positioned correctly at the right time, at the right location, then we might be able to even monitor and assess the situation and provide early response and emergency response to those flood-prone areas.
Volcanoes. I'm also a big volcano nerd. I mean, they're really cool. So, or they're not really cool, I guess. So with volcanoes, how can it be used to study volcanoes?
Absolutely. So volcanoes actually deform because of the magma movement beneath its surface. And NISAR will provide a comprehensive global coverage, especially in these volcano-prone areas. And by looking at some of these processes, we'll be able to, again, provide response where it's needed the most, and especially for these volcanic eruptions.
I mentioned earlier that there's so many other satellites we have studying the planet. Where are we currently not studying? What gaps does NISAR fill? What could we possibly look forward to in the future?
NISAR, actually, with its unprecedented detail and consistency, and also over its 3-year mission, will produce more data, actually more than any other Earth-observing satellite. In fact, all of the Earth-observing satellites combined. So if you were to take NISAR data and stream it on a streaming platform, it would take us 100 years to get through all that data. So that's the amount of data we're collecting. We're looking at earthquakes, landslides, glaciers, biomass, forests, you name it, we have it all covered with NISAR.
Okay, with that amount of data, how do you get that amount of data from space to Earth? And then once it's here, how do you dissect it? Like, I assume because there's so much, there has to be like some methodology, right?
Absolutely. So NISAR data, the amount of data that we're actually collecting required a whole new downlink infrastructure to be developed for this mission specifically. We have scientists building science data processing pipelines to look at this ginormous amount of data, but also we will have this freely and openly available for the public. That, I think, is the best part about NISAR.
With this type of data, I've talked to a lot of scientists who talk about the usage of AI to kind of look at data that this amount of information. Will that be utilized in any way, shape, or form by NASA to dig through this information?
Absolutely. I think AI is one of the tools that will be used in this mission and future missions, and it's a very powerful tool to look at large amounts of data and look at specifically patterns in those data.
How long is NISAR's mission? How long are you hoping it lasts? I know some of these kind of go a couple years past what people are initially anticipating. And then once it's done, what's the next step?
So NISAR is a 3-year mission, and over the course of the 3 years, NISAR will serve as an early monitoring, assessment, advanced warning system, and a response system to policymakers, scientists all across the globe. That is the goal for NISAR, and hopefully with NISAR that will open up new doors in every single area that we're going to be studying.
Finally, when's the launch date? When's the time? Give me all the details. When can we see this thing go up?
Absolutely. NISAR is all set for launch no earlier than July 30th.
July 30th.
July 30th coming
And
up. My
it's
brother's birthday. And
Ooh.
don't quote me on this, but I'm going to say it on TV anyway. I think it's Jim Spencer's birthday too.
July 30th?
I'm pretty sure it is. Yeah,
I think that's the National Jim Spencer Day.
no, National Jim Spencer Day is my birthday.
Oh,
February
what?
25th. Yes. It is the only person I would share my birthday with is Jim. And every year he gets a lovely text from me and I get a lovely text from him.
That's funny.
So yeah, it's very fun. That was Dr. Akshata Krishnamurthy. She is this is the part I forget, the NASA JPL science phase lead for NISAR. So she's the science in charge for NISAR, which I actually don't remember what the full thing for NISAR stands for. Call me a fool. I don't remember what NISAR stands for. It's a really long name, guys. Like some
I'm
of these
sure
are.
it's full of numbers
It
and letters.
is like, I try my best on these, and I'm gonna look it up. Hold on, I feel full. It is. Well, this doesn't help me at all. It just tells you who put it together. I'm gonna get it to y'all. I have no problem embarrassing myself. I play the fool because I are one. It stands for. Where is it? Doesn't say. Oh, here we go. NASA ERSO, which is the Indian Space Agency, synthetic aperture radar.
That was pretty simple.
So NISAR. We'll just call it NISAR. You can tell why I did not bother memorizing that one at all. That one was, gosh, some of these names. And they're so scientific. What was I listening to? I was listening to a podcast yesterday, and they were talking about like scientific names. Oh, it was like athletes. It was a type of like working out. And they were talking about the actual scientific name for basically like when you're working out, you're supposed to change your exercises up. And a few years ago, there was like a really long scientific name the science community came up with.
About changing your exercises?
Yes, and then it was like Gym Bros like totally gave it a different name, but the new Gym Bro name wasn't any better. It was like there was not a good name. They were all super long names. I'm like, why? It just change your exercises every day.
That's gonna make me not want to change my exercises.
Right. I'm like, sometimes it's science. I love science, but sometimes the names I'm like, y'all need some marketing help. But NISAR is much better. NISAR is a good name.
And this is going to last 3 years, right?
3 years, yeah. And I actually asked, and I removed this, is there going to be a NISAR 2 or 3? Because a lot of times when they do these missions, there is like several follow-ups, but the answer was kind of like, well, we're going to see how this one succeeds. Yeah. So this is kind of how it works. We'll get one up there and take a look. But the amount of data, they said basically it gets within a centimeter of how much of landmass. Yeah. They'll be able to use it to track it. And I actually didn't ask about this. I really was curious, but I was trying to be respectful of their time. But it'll be used for tracking like glaciers and like water flows, stuff like that.
And earthquakes.
Earthquakes is what I did. Yeah, I wanted to know about that because the earthquake, they can actually see how much the land has moved within a centimeter. And I did ask about the Kerrville floods. Could it have helped with that? And they did tell me like if the satellite was in the exact right spot, it could have helped predict flooding along those lines. But it has to be in the exact right spot. And this is a small satellite circling the planet, gathering a ton of data. It's going to be used more for like long term. So while that is a possibility, could help with predictions, it is very in predicting like kind of natural disasters. It could help with those, but it has to be in the exact right spot at the exact right moment. So the likelihood of that is low.
Slim. But
it can get a lot of data, and that data can be used to help us here back on Earth kind of predict it. And the amount of data they're getting with this thing is bigger. It's more than any other satellite's ever gotten, which is why it's going to be fed back and just ciphered through. And we talked a minute ago about like looking for that one planet and that one star in all the cosmos. This is the inverse of that. It's looking at the 1 centimeter, the centimeter on Earth. Yeah. And that's what they're looking at. That's an insane amount of data, an insane amount of detail. And I know we have lots of issues with the AI.
But they are using it to do this.
It could be, AI is one of those things that has like its benefits and its negatives. But one of the benefits is when we're talking about these storehouses full of data, it's so good at looking at data. It's so good at it in the way that my eyes just glass over. There's times where I'm having to look at like a single Excel spreadsheet for like a story, and I'm looking through it, looking at lines of numbers, and my brain just doesn't calculate that. AI is so good at that kind of stuff.
We all wish we had a Christopher Breen, our data
I know.
analyst.
Christopher Adams, our data analyst here at KXAN, he can look at those things and boop, 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 and understand it fully. My brain, like I can look at like a page and
get lost.
It just all totally like eventually. I can do it. It's just hard, right? It takes twice as much work. Where AI can just do it like that. The other thing they use it for, and which is really important with NISAR, is I've talked to a lot of scientists about this. It's really good at image recognition. So looking at two different pictures and going, these two are different, and here's how. AI is really, really good at that, much better than we are as people.
Gosh, I remember those little exercises we had when we were younger. Right. I was never good at those.
Right, and it's something like we can do, but
it takes time.
It takes a little time. AI does it instantaneously. It's so good at that kind of information gathering and interpretation that in a very neutral way, not in a positive or negative with AI kind of way. It's very neutral in that kind of stuff. And so with something like NISAR, the amount of data it's pulling in, that's going to be an invaluable tool moving forward. And it could help us, do things like predict earthquakes, predict landslides, predict flooding because of the amount of data. It will go gather, and then we'll be able to interpret.
In a perfect world, we would have been able to do that during our flooding here in Texas, but hopefully in the future,
Yeah,
as
I mean,
technology
it's all about,
advances.
with some of this tech, it's like, what can we do in the future, right?
Yeah.
And I think we forget sometimes with like, why are we sending a satellite into space to blah, 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 blah. It's all about the next step. It's all about the next thing. It's the
How
next
are we going
thing.
to help ourselves?
And it'll gather, why do we want to go to Mars? It isn't really about going to Mars, although I think it's cool and I want to do it.
It's not about finding aliens, but
Right, it's
if
not
we
about
do,
that.
that's a
But it's
plus.
about developing the technology that can be used here on Earth. It's a
Yeah.
full cycle thing. The stuff they need for, creating the oxygen, the environments, the stuff they need on Mars, that could be used in deep sea diving. And then when we're deep sea diving, we may be able to find new resources here on Earth.
Minerals.
Right. And then also, find the resources on places like Mars or in asteroids.
Yeah.
Yada, yada, yada. So it's like all these things are kind of reciprocal. And, the power of your cell phone, this is more powerful than the first lunar lander. Right.
And that is crazy.
And it's in the palm of your hand. And it's like, I think it's like 1,000 times more powerful. Some ridiculous number. So, these technologies are all about building on the next thing and then helping us back on Earth. And the information that NISAR is going to get us over the next 3 years will play a valuable role in the future of how we predict environmental changes here on the Earth moving forward.
Well,
There's my lecture for the day. Science matters. Science is important. This is why. There
and
you
it's
go.
not
Space
just
base.
about a hot Jupiter.
It's not just about a hot Jupiter.
There's more.
Yeah, there's more. Maybe a hot Neptune. That'll be the future.
Yep.
Anyway, that's
It's
all I
gonna
got for
look
you.
like that. Well, we have your article that you published this
Yes.
morning. It is here on our homepage.
Cool photo by the
KXAN.com.
European Space Agency right there, kind of showing what it looks like.
Kind of looks like a jellyfish.
Kind of as it's being stripped away. Pretty cool. Nothing else crazy in there. You can get a link to the full research if you really want to dig into there. That's all available for you.
Well, thank you so much for joining us, Eric. I do want to remind everyone that Eric and I do a space show every Tuesday morning, and that is also played out on our KXAN Plus CTV programming app. Eric, where can people find that?
That is on everything. Apple, Roku, Samsung TVs, finally. I can watch it at home. That one took a little bit of time. I'm a Samsung guy. But
It did.
There's one other I'm missing. What is it?
Fire TV.
Fire TV. Yeah, I don't have a Fire TV.
Yep.
I always forget that one too. But it's weird because you can get those now on your Samsung TV. It's a whole it's consolidation, man. Like
It's
I
a
have
whole
theories. I don't know.
subscription thing.
Everything feeds into it. But like my mom has like a Fire Stick in one room, a Samsung TV in another room, and then an Apple TV in a different room.
Me too.
It's just too much. Although I do have echoes in every room, listening to every word I say.
Dropping in.
Yeah,
Well-
controlling my lights pretty much is the main reason we have them.
Wow,
Yeah.
nice. Well, this app is completely free. You can download it on your app store on any TV that you have now.
Yep.
We are also on Samsung. So download that app, KXAN Plus.
Absolutely. And you can watch our full feature-length documentary, Family Beef, which is on there now.
It's always
I'm
playing.
going to keep promoting that as much as I can. That was a year of my life. Not giving up on that anytime soon.
And it's awesome. It's an awesome watch.
Thank you.
I recommend it to everyone. Well, thank you, Eric. See you next week.
See you next week.